Okay, so we'll wrap up chapter 7 today. The topic is confidence intervals. We are going to skip chapter 7, section 5, because it doesn't exist in the first edition of the textbook, and I know some of you, and there was like that mishap with the textbook versions at the beginning of the quarter, so we will have to. So we will skip chapter 7, section 5. Okay? It's missing from the first edition. So I guess if they wanted to justify the second edition, it was the edition of section 7.5. I don't feel like we're losing too much by skipping this section. If you really want to know, you can come by during office hours. I'll be happy to explain what's happening in there. Okay, but I think we still have a good amount to cover and talk about regarding confidence intervals. Okay. Okay, so let's start off with a question, a clicker question for you guys. Let me set up the problem here, and then I'll give you guys some answer choices. So, okay, so we wish to know what percentage of people own a vehicle. Okay. All right, and actually I have no idea what this number is. Okay, so we somehow obtain a random sample of 550 people. Okay. And we find that in our sample, 350 own a vehicle. Okay, and okay, so we'll say use this information to make a 90% confidence interval. I've talked about 90% confidence, right? Did I? I don't know. Okay, well, try it out anyway. Okay. To make a 90% confidence interval for the proportion of people in the population who own a vehicle. Okay, and so try that out. Let me come up with some answer choices for you guys. Okay, so let's see. And let's see. Okay. Okay, I'm about to hit stop here. Okay, let's see. The correct answer is B. Okay, so a lot of you guys got that right. Some of you guys got it wrong. Okay, let's see how we should approach this. Here we have a sample of 550 people. So our N is 550, and then of those, 350 own a vehicle. So our X is 350. So our P hat, our sample proportion, is 350 divided by 550, which is, let me just punch this in here. 350 divided by 550, we get 0.63636, okay? And we want to create a 90% confidence interval. So our confidence interval is going to be P hat plus or minus a critical value Z star times our standard error, the standard error being P hat times 1 minus P hat over N, square root of that, okay? If we're looking for the middle 90%, okay, then we would want 5% in each tail, and that would lead us to a Z of plus or minus 1.645. Okay. So if I just plug in these values, I got 0.63636 plus or minus 1.645 times basically 636 minus 1 point divided by 550. Okay, and so to get that, I'm going to just do answer 0.63636 times 1 minus that value, 1 minus the answer, divided by 550. I hit enter. I'll take the square root of that, and I got 0.0205. So I have 0.63636 plus or minus 1.645 times 0.0205. All right. And so I'm going to multiply that by 1.645 plus or minus 0.0337. So all right, and then and so if I combine these, the values that come out to be closest to what I have listed are the values in answer choice B. Okay. Is that okay? And so the statement we would make would be something like, I am 90% confident that the proportion of vehicle owners in the population is between 0.602 and 0.670. Okay. Just want to make sure we're good with this. Okay, so let me, I'm going to just copy this statement over, and then I'm going to ask questions based on this statement. So this is our confidence interval, our 90% confidence interval. Is this, right? So here we are saying we are 90% confident that the proportion of vehicle owners in the population, because it's always a statement about the population proportion, we're 90% confident that it's between 60 and 67%, essentially. Okay? All right. So here's a question, okay? Do we have, do we have evidence that the proportion of vehicle owners in the population is not 67, or I'll say 0.6, what's going on, is not 0.675. Okay, and we'll say at 90% confidence. Okay, and your answer choices are yes or no. I have a feeling everyone's going to be angry with me on this, so... Okay, I'm just seeing how the answers are coming in. I give you a chance to change your answer. Let's see. It's not intended to be a trick question, but this is one of those situations where certain phrases are okay and certain phrases are not. I'll give you the answer here because I don't want to piss off all of you, okay? All right, so I'll give you the answer. You can change your answer after I reveal the answer, and then we'll lock in the thing, okay? All right, so it says, do we have evidence that the proportion of vehicle owners in the population is not 0.675, okay? And then we're basically saying at 90% confidence. And we look at our interval, and we see that 0.675 is what? Is it inside our interval? No, it's not inside our interval. It's outside our interval. So it's we would say 0.675 is not within our interval. Okay? So we do have evidence that the proportion is not 0.675, okay? Okay, so you can change your answer there. Okay, 2 people haven't changed their, okay. Oh, okay, yes, everybody, okay, all right, so there we go. So, yeah, now everybody has the correct answer. Okay, so this statement is okay, all right? Do we have evidence that the proportion of vehicle owners in the population is not 0.675? That is okay, all right? But if the statement said, does this prove that the proportion of vehicle owners is not 0.675, the answer would be no, okay? So does this prove that the proportion of vehicle owners in the population is not 0.675? And the answer here would be no, okay? It's a statement of confidence, all right? We are 90% confident about our statement, okay? So when we say we have evidence against 0.675, that comes with a kind of a little asterisk that says I'm 90% confident about this statement. Okay. If I had bumped it up to 95% confidence, okay, my interval would get a little bit wider, right? So let me just copy everything here. Okay, and so if I had bumped this up to 90% confidence, how do I? So let's say I want to delete all of this, okay? Okay, so at 90% confident, or 95% CI goes from, what would it be? It would be this divided by 1.645, and I would multiply that by 1.96. So 0.595 to 0.677, okay? Okay, so if we wanted to be 95% confident, our interval would go from here to here, okay? So then, in this case, if we had asked the same question, okay, but this time at 95% confidence, okay, what do we see? Is 0.675 within my interval? It is, okay? So at 95% confidence, my answer here, do we have evidence that the proportion of vehicle owners in the population is not 0.675? Our answer here is now no. We would say 0.675 is within my confidence interval, okay? And so we would say according to the confidence interval, according to the confidence interval, 0.675 is a plausible value for the population proportion P. Okay, and so we do not have evidence that it's not 0.675. I know that's a double negative and it's not favorable to write things like that, but I can't think of how else to write it. Okay, we do not have evidence that it is not 0.675. Okay, so for in this case, our answer is now no. Okay, so just changing the confidence interval, these values that are kind of on the boundary switch from is it plausible to no longer plausible and things like that. Okay, so how can I'm basically the data hasn't changed, right? I've looked at the data hasn't changed. We're looking at the same data, and it's just all we did was we changed our confidence level, and suddenly my answer to this question switches from yes to no. Okay? Is that okay? And the answer is yeah, that's how this works. Okay? It's how it works, and it's just, if it feels uncomfortable, it's just a matter of how certain do you want to be in your answer. Okay? And because at the end of the day, if you're forced to make a yes or no decision, it's difficult to do, okay? And so if you're willing to reduce your level of confidence, okay? So if somebody asks you, do we have evidence that the proportion of vehicle owners is not 0.675? If you're willing to be less confident in your answer, if you're willing to be only 90% confident, you can say, yeah, I've got evidence against that, okay? But you could be wrong, right? If you want to be more certain, then you're going to be a little bit more cautious, okay? You're going to say, no, I don't have evidence against it. It is a plausible value. And that you're just being a little bit more cautious by saying I'm 95% confident, okay? Is that okay? Are we feeling okay about this? Okay? It's the same data, and it's a matter of how much confidence do you want in this interval, and if you're willing to be less confident, you can have a smaller interval and make some more decisions, but you end up being a little bit, you're going to be wrong. So it's the difference between someone who's maybe a little bit of a, quote, risk taker versus someone who's a little bit more cautious. Either approach is fine in life, okay? But they both come up with their little trade-offs, okay? Other statements based on these confidence intervals. So let me just kind of copy this again. So I guess at this point I'm assuming that we're okay with the calculation of confidence intervals. That first question with calculating the confidence interval, like most of you guys got that right. So I'm hoping we're okay with the calculation of the confidence intervals. There's just a lot that goes into like what kind of conclusions can we make from the confidence interval, which in my opinion is just as vital or important as coming up with the confidence interval itself, okay? And in fact, a lot of times today we just throw numbers at a computer and the computer spits out the confidence intervals. It's the interpretations that prevent us from being replaced with computers, right? We're all gonna lose our jobs to computers anyway one day, so maybe. I'm like, I don't know, okay. You guys are here at UCLA, so you have a better chance of surviving the robot apocalypse. I don't know. Okay. So we've got our confidence interval goes from 0.602 to 0.670. Okay, so here's the statement. Can we say, and we'll make another clicker question out of this. Okay. We have evidence that the population proportion of vehicle owners is 0.650. True or false? So we're using the same confidence interval at 90% or 95%. For both of those, 0.650 is inside the confidence interval. So can we say we have evidence that the population proportion of vehicle owners is 0.650? This is another question. Discuss with your neighbor. You can decide what. Okay, get your clicks in. Okay, and I'm gonna hit stop. Are you guys ready? Okay, this one, it's like the class is very divided. So, what is the answer? It's C. No, it's B. Okay, all right. Let's discuss. Okay, do we have evidence that the population proportion of vehicle owners is 0.650? This is not true. All we are saying, this confidence interval, 0.650 is inside the confidence interval. That is true, okay? So 0.650 is within the confidence interval. Okay, that's true. That we are not denying. So we are saying 0.650 is a plausible value, but it doesn't prove, or it doesn't say that the proportion is 0.650. All we are saying is we can't eliminate 0.650, but it doesn't mean that it is 0.650. Okay, so 0.650 is a plausible value. I don't have to put quotes around it. It is a plausible value. Okay, but it is not necessarily, but the proportion is not necessarily 0.650. Okay, and we cannot say that we have evidence that it is 0.650. Okay, so we can say, so when you create a confidence interval, okay, or do I need to go back? I don't know. Here, I'll just, I'll flip back, let you guys finish writing that. I'll draw a little picture, but basically when we're creating a confidence interval, we are just creating kind of like a region of stuff that we can reject and say, okay, we're pretty sure that it's not this, okay? But again, it's just pretty sure, probably. Yeah, question?
So why does the is in the positive version make it concrete and not in the like not version?
Yeah, this is like, everybody hates this. It's, I guess it's kind of like, just because you don't have evidence that someone is innocent, so you might not have enough evidence to prove someone's innocence, that doesn't prove that this person is guilty. Okay? So in with our, so if you imagine our court system set up in our country, it's the burden of proof falls on the prosecution, right? So in a criminal trial, if you want to, the burden of proof falls on the prosecution, and so the prosecution may bring a lot of evidence and convince the jury that the defendant is guilty. Okay, but there could be a case where there's just no evidence on either side. Okay, and in that case, the default is there was not enough evidence, so we're going to let this person go free. Okay, but the lack of evidence actually doesn't prove that the person is innocent or that the person is guilty. It's just there wasn't enough evidence to bring a conviction. Does that prove that the person is innocent? No. Okay. We'll revisit this same idea here, but it's just because 0.650 is inside the interval and it's a plausible value doesn't mean that the population proportion is necessarily this value. Because I could write just a parallel statement, right? And if you said it's true here, if I wrote another statement, and I just wrote, we have evidence that the proportion is 0.640. Or something like that. Okay, so just imagine I wrote a parallel sentence, okay? So if you said that the answer is true for this sentence, then you'd also have to say the answer is true for this sentence, right? Because using the same logic, 0.650 is inside the interval, you'd say, oh, okay, true. Okay, and you'd look at this, 0.640 is inside the interval, you would also answer true. Okay, but obviously that can't be the case, right? We can't say the population proportion is 0.640 and at the same time 0.650 and at the same time 0.6 whatever, okay? We can't say we have evidence that the population proportion is 64% and we have evidence that the population proportion is 65%, okay? We can't say that. All we can say is that 64% plausible value, 65% plausible value. But is it proof that it's any of these, or do we have evidence that it's actually any of these things? No. I don't know if that clears things up or just further confuses you guys, but I'm hoping that helps, okay? So when you create a confidence interval, basically you can imagine just we have a number line, okay? So this is a number line, okay? And as far as proportions go, they can go anywhere from 0 to 1, okay? When you, your sample will have proportion p hat, okay? So this might be p hat, okay? And you create your confidence interval and you go out basically here to here. This is technically our margin of error. So the margin of error, sample proportion is p hat. Our margin of error would be the z star times p hat times 1 minus p hat over n. Okay, so we say p hat plus or minus the margin of error basically. And all we are saying is at the end of the confidence interval, we're saying everything from here to here, these are plausible values of the population proportion p. Okay? And everything out here, these are implausible values, okay? Okay. And basically we are blank % confident that p is inside this range of plausible values, okay? Okay. Could p be in the range of implausible values? It could be, but we're fairly confident that it's not, okay? Blank % confident that it's not. Okay. Last class I said it is wrong to talk about the probability that p is inside the plausible range, okay? So what exactly does it mean to be 95% confident, okay? So let's just talk about, what does 95% confident mean? Okay. So let's say, I don't know, let's say we had a big tub of M&Ms, okay? And we wanted to estimate, try to figure out the exact proportion that's blue or something, okay? And so let's say I had each of you go in there, take a sample out and count how many M&Ms are blue or something. And then every one of you created your own confidence interval. Each one of you got a different random sample. Each one of you created your own confidence interval, okay? So we've got our tub of M&Ms, okay? And then so each student takes their own sample. Gets a random sample. Each student makes a 95% confidence interval, okay? What we would expect, okay? Now, when you look at your own confidence interval, you have no idea if your confidence interval is quote-unquote correct or wrong, okay? In that you have no idea if P is actually inside your confidence interval or not, okay? So when you look at your confidence interval by itself, okay, you do not know if your confidence interval is, quote, correct or wrong in that did it actually capture the true value P. Okay, you don't know. But we could go through and we could actually go into the population, count all of them, and figure out the true value of P in the population. And if we revealed that true value of P, we would expect that 95% of these intervals would actually capture the true value of P. Okay, so we can reveal the true value of P, okay? And we would expect 95% of those intervals to successfully capture P. Okay, capture P meaning P is within the interval. Now you might say, well, that sounds a lot like 95% probability of getting P, okay? It sounds like that, but it's not, okay? Because when you create your interval, you have a set interval, and then you're talking about P. Here, when we talk about a 95% probability or percent chance, what we are talking about is the process of creating a confidence interval, the process of getting a random sample and creating a confidence interval based on that sample. So if we want to force ourselves to use a 95% probability, it would be correct to say that when we take a random sample, this is where the random or the uncertainty comes in. When we take a random sample, there is a 95% probability that we get a sample whose p hat is close enough to the true value of p so that our resulting 95% confidence interval, successfully captures P. Okay, so it's in the random sample. When you get a random sample, there's a 95% chance that you got a random sample that gives you a P hat close enough to P for it to work out, okay? But because of random chance, it is possible that you happen to get too many, too many blue M&Ms or too few blue M&Ms, okay? But 95% of the time, your random samples will get about the right amount of blue M&Ms so that your P hat is close to the true value of P and your resulting confidence interval captures the true value of P. I hope that makes sense. You can study this exact sentence a little bit more But that's where the 95% comes in. Okay, sorry for going a little over today.